A full adder is a combination circuit. Obviously we are studying everything under the roof of the combination circuit that forms the arithmetic sum of three input bits. Well, that's the changing point that we have, and it consists of three inputs and two outputs with two outputs. Well, that's very powerful when you reach to this point, because previously when we are studying, we are just studying about the two inputs, which is x and y. X and y are our two input bits, but now we have option of three inputs. Let's see more about that. Well, so I would like to mention here the table that we are going to have here. So let's just do it. Well, here we have inputs actually, and then we have output. So now we are going to make a table on this basis that is going to tell us that how the inputs and outputs are actually gonna work. Well, before that, let me mention that in the case of input we have x, y, and z or z, whichever way you like to call it, and then c and s. Well, can you guess this? X, y, z are just the simple input names, but what does it mean of c and s? Can you guess that, my dear friend? Absolutely correct. C is for carry and S is for sum. Excellent. So those of you who have remembered this, I am proud of you. C is equals to carry, because when you do add, you need to carry sometimes, and S is the sum. Now let's do it. Let's put the inputs on various ranges. So we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and then we have 1, 0, 0, finally 1, 0, 1, 1, 1, 0, and finally 1, 1, 1. Well, I did not count it that, so let's count it also. I hope so that it's correct. So let's see how much correct I have got. This is 0, this is the first input, this is the second input, this is the third input, this is the fourth input, this is the fifth input, this is the sixth input, and this is gonna be the seventh input. Well, if you are wondering that how I am correct and how confident, why so much confidence I have in making this table, and how to remember that when to write 0 and when to write 1, so let me tell you, because this is one of the problem that I have also faced when I was studying, and I later found a key idea for that I taught to all my friends, and after that they have found it very easy. So let me tell you that too. Well, it's 0, 1, 10, 11, change. 0, 1, 10, 11, and change. Well, this is my pattern. If you notice that, so it is 0, this is 1, this is 10, this is 11, and this is change. Change means you have to shift the place of 1. Well, in all these places it's 0, now you have to write the 1. And then again 1, 10, 11, and if I write further, it will go on for the change. Means if I write the 8th input, which is not required here, but if we decide to do that, this is gonna be our 8th input. Well, I hope you have understood the idea of presenting the inputs. Let me remove all these things, and now we are going to write about the answers that we are all waiting? Well, for the carry, it's 0, 0, 0, 1, and then after 0, 1, 1, 1. And finally in the sum we have 0, 1, 1, 0, and then 1, 0, 0, 1. Well, okay, this is something we understand, but just tell me that how in the world I remember these many zeros and ones. How is it possible? Is there a way, a trick, or some calculation? How I remember these zeros and ones? Well, let me tell you, and let me help you with that, my dear friend. Well, divide it into 4 and 4 parts. Well, this is totally the trick, and obviously based upon the reality, but it will gonna be simple one. Okay, so the first one in the carry we are seeing, in the carry we have, if you look it closely, this is just the AND gate, and this is nothing, just the NAND gate. Okay, so AND gate input and NAND gate input, and the sum we have XOR. This is the outputs for the XOR, and this is for XNOR. Well, now you do not need to remember all the zeros in one sequence. You can just remember, write down and then NAND for the carry, and for the sum you have to write XOR and then XNOR. That's the whole idea of it. Well, I hope you have understood all these things, and obviously this signifies these terms. I'm trying to present it because it's gone a little up and down because of my writing style, but I hope you have understood all the things that you need to know and learn, my dear friend. Okay, so we have these all things. So why I'm drawing these lines is actually just to signify that we can maintain the pace of it. Okay, so I hope you have got the entire point, and I'm waiting for you to just look all the things just once more. Okay, I am done with that, and I hope you have done with that either. Now it's time to learn that how it actually appears, just like here, how it actually seems. Well, now we want to see it, that how it actually sees. So let's watch it together. And now we want to create it. So to create it, we need, first of all, let's choose the white color itself. Now we have, okay, I'm just writing everything. Try to recognize that which are the gates that we are using. We know that we have to use AND gate, NAND gate, XOR gate, and XNOR gate. How I am knowing that all? Because of these. That's why I told you this before. Okay, now let's begin with this. And guess that what is happening right here. Okay, I'm not writing any kind of the inputs for right now, I'm just drawing it all. And surely there is a question for you, so try to figure out first. I'm just drawing in the meantime. Till that point, keep pondering. Pondering is the best thing you can do so many times. I would like to do. Okay, now I need to make the connections. So let me connect it in this way that becomes helpful for understanding the things quite clearly. This is gonna be here, and this is gonna be here, and now we have one more which will gonna be here, and now what else we want from here? Okay, let me change the color also. So these is the points of the ultimate inputs, which is X and Y. And surely we need an input that is called as Z that I'm placing. For right now I'm placing it here. We will connect it with the wires in just a while. Okay, so with the Z I have to put it in here. Okay, and then I have to place one more dot in here. Placing one more dot in here, you will understand that why I'm putting these all the dots and all that things. Just look at the creation. Okay, let's change the color. Actually, let me change it a little bit so that we can see the things quite clearly. I am making it here. Okay, now just connection time. So in the connection time, I am okay. Let me do it in a simple way so that you understand everything along the way, and you don't need to wait all the way long. Okay, so let me write it down. So why I'm going to write it down? Here we have x XOR plus. Well, I'm mentioning XOR plus so that you understand that what it actually means. Y and finally Z. Well, this is gonna give us the sum, and this is for the carry. This is for the carry, and for the carry one we have x plus y times z plus x y. Well, how I'm writing this, you will know in a while. X y, and what else I should write? I should write x plus y times z. Okay, what else I want? I want here x plus y. Okay, I hope we have done all the possible things, and now just the connection time is left, and I'm going to connect these things. Okay, this is connected, and this is connected, and what else I want here? Okay, I need to connect this here, so I'm gonna give this input to this one, and the y input to this one, so that we can get x and y together. And this is the z functioning. I think all the connections are done. Let's check it out once more. So we have x and y connected and z connected as the inputs. Now the xy is in here for the carry, that gives us the xy, and this is the point for the z. In the z we have another AND gate which is working for us, and this is XOR x plus y, and this is for the z kind of the input that is given from here that we have in its input line, and finally this is going to give us the carry. Okay, I hope you have understood the connections. If you not, don't worry, it will bother you a little bit, but I hope you will get through all that things quite clearly in just a while. Well, this is combinational circuit for full adders. So what are the advantages of full adder? Well, one of the advantages, as you can see, we can get the 3 inputs. Because of the 3 inputs, we can have the 8 possible combinations. So now we can do the octet system very clearly, and it's helpful. It's very much helpful. That's why we are learning it. Well, I hope you have learned this one. And just the last thing that I would like to mention here is, well, we have gone through the XOR gate. I'm just writing the gates, then I will tell you that what I am willing to tell you. And this is the AND gate, this is the OR gate, and this is the XOR gate. Okay, this is gonna be interesting one, and this is the AND gate. So looking at this combination, you can clearly understand that we are using 2 AND gates to XOR gate and 1 OR gate. So OR gate is there for the addition, XOR gate is there for the logical addition that we need to do, and the AND gates are for the multiplication purposes. but ultimately we are getting the results. That's the ultimate thing. Well, how it's working, it's very beautiful, because before even building that, we have already worked on this thing. On the circuit part, it seems a little bit complex when you try to think about this all the things, but you will get familiar with that because we have already included the inputs and the desired outputs that we want. So we already know the questions and the answers, and now just the thing is million times and billion times it is coming in different combinations, but we surely know that what's gonna be the output. That's the advantage of the digital electronics. So congratulations my dear friend, you have just learned the combinational circuit for full adders. In the next one we are going to learn about the subtractors. Till that time, take care, God bless, and Namaste.